So today we'll be talking about descriptive statistics. I want to be sure that everybody is hearing me. I want you to confirm. Okay, that's great. Descriptive statistics. Yesterday we discussed the logic of scientific reasoning and the basic concept of statistics. We also, in the practical session, we also look at how we could explore, going around the SPSS window, familiarize ourselves with the SPSS window, then how to create variable and how to enter data. Today we'll be looking at descriptive statistics. Then during the practical session, we'll be able to look at how we explore data, how we can run some little go around data before we go to the specific. This is one of my maxims. Statistics and management are two faces of the same coin, which is evidence-based decision. Statistics provides the evidence while management makes the decision. So I don't want to waste much time on that. When we talk about descriptive statistics, we have already said yesterday, we differentiated between descriptive statistics and inferential statistics. That is, statistics as a subject is divided into two. That is two parts. If you define statistics, you say it's the science and art of collecting, collating, analyzing, summarizing, analyzing, and interpreting data. We now say from collection up to summarization, that is descriptive statistics. And you do that for sample. That's what you do for sample. While inferential statistics is how you make judgment about the population parameter from the sample statistics. So descriptive statistics, the first thing you want to know about descriptive statistics is the concept of distribution. What does it mean when you say, many times you hear age distribution, sex distribution, distribution of response according to occupation. You use the word distribution. What does it mean? Distribution means pattern observed in the collection of value for a variable. That is how often we see the various value in a data set. That is the pattern you see in a data set of the value of the variable. For example, we want to give example. Before I go to this example, if I decide to give each of you in this class a sweet, maybe I come to class, I give some 1 sweet, some 2, some 3, some 4, some 5, at random like that. So if we say the variable now, number of sweet each person receive from me. So if we now say, okay, who are those people? Because the number of sweet can be 1, can be 2, can be 3, can be 4, can be 5, as I've said it, but different people will receive different number. If I want to know the distribution of the number of sweet each person receive, the class receive, what I will do is to ask how many, if you are 50, how many of you receive 1? Maybe 9. How many receive 2? Maybe 12. How many receive 3? Maybe 7. How many receive 4? How many receive 5? So everything will be added to 50. So the number that receive each value is the distribution. The distribution, that is, out of the 50, how many people receive that value? Receive 1. How many receive 2? That is the distribution. But that distribution in the simple way is what we call frequency distribution. Because from that, we have 4 types of distribution: frequency distribution, relative frequency distribution, cumulative frequency distribution, and cumulative relative frequency distribution. So we'll move further. The example I've tabulated here now to explain all these 4 types of distribution. We have an example here. So we have example of 50 people. These women with ovarian cancer. This is the distribution of their parity. Just forget about ovarian cancer. Let's just take about women. Parity for those who are non-medical people or health people. No, it will be easy for doctors and nurses to understand parity more than any other person because they are used to it. The meaning of parity is number of time a woman carry pregnancy to term. Carry pregnancy to term. That is the pregnancy reach 9 months or anything approximated 9 months. Term, we say term pregnancy. That is complete the duration. If something got aborted along the way, it's not parity. But the number carried to term, it may be live birth, it may be stillbirth, it doesn't really matter. It may be by tears, but the issue is that you carry the pregnancy to how many times? That's the meaning of parity. So that you can understand what we mean by parity here. So here now we have 50 women, and it's possible a woman has not carried a pregnancy to term. So the value of parity can be 0. It can be 1, can be 2, can be 3, can be 4, it can be more than that. But for these 550 people, we don't have more than 50. Or maybe more than 5 rather. More than 5. Maybe we say 5 right now, but let's say 5. So among these 50 people, we have 0 to 5. So we want to know the distribution. So that I don't like. So there is main and there is depth. By Guido, I will send you out. The person that disturbed me in the class. Okay. So you can see, hope you can see the screen. So number, if you now look at it, let's look at the first type of distribution, which is frequency distribution. You will see that out of 50, the para 0, the people that have not carried to term are 15 in number. The people that carry to term once are 11 in number. Twice, 8 in number. 3, 6 is number. 4 times 5 in number. 5 times 5 in number. If you add everything, make it 50 because there are 50 women here. So the frequency distribution just means the number in each category out of the total. So we have 50. If you look at it, you have 15, 11, 8, 6, 5, 5. It gives you 50. But this type of frequency distribution is not so useful in the sense that for comparison, okay, this is 50. If another person has 80 now as number of how do you compare? If we say, okay, in this group, there are 15 that are para 0. If you have 80 women, if you have maybe 16 that are para 0, how do you compare? We not say 60 is more than 15. No, we cannot say that because the total is not the same. So some people will do study now, it will be 400 people. Some people will do study 800 people. Some people will do study 250, 300. So what are those 200? So you have different sample size. If you just use distribution, you'll not be able to compare the result from those studies because they don't have the same sample size. So the intelligent people now came with the idea. Instead of just say the frequency distribution, with the number of time that thing happened, and the number in that category that had a particular value, we now change the number to percentage. That is, we standardize it by saying, okay, 50, in this case now 15 over 15 times 100, it gives us 30%. 11 over 50 times 100, it gives you 22%. The third one, the people that have 2, 8 over 50 times 100 give you 16%. Just like if you now add all the percent together, it will give you 100. Just like the way you had all the frequencies together, give you the total, your sample size, in this case, which is 50. But when you standardize it, you change to percentage, the total will be 100. So even if the sample size is 100, is 400, is 300, and even any sample size, once you have standardized it, you have changed it to percentage, you'll be able to say, oh, 30% here, this was 32%. You know that 32 is not the same thing as 30%. So by using percent, that percentage is what we call relative frequency distribution. Can you see? When you express the frequency in percentage, we call it relative frequency. So you'll be able to compare in between different studies. That is why when you are doing yourself, you quote, you say so at all. You know, percentage of people that have received vaccine, HPV vaccine among the children, female children, they are is so in our studies 11% here, in other studies 20%, in other, because you're able to do the relative frequency. If you just use the frequency, it doesn't make sense. If your sample size is 1,500, you just say about 250 receive. So it doesn't make meaning. If another person does study and they are using 33,000 as sample size, how do you compare? Is by expressing as relative frequency, which is relative frequency distribution. Now, going further also, you have another type, which is cumulative frequency. In this case now, instead of just say, okay, we have frequency 15, 11, 8, like this, when we arrange it. If you have arranged it in ascending order, like what we have done now, the parity have been arranged in ascending order. The value of the variable you are talking about, possible value have been arranged in ascending order. So what you do in cumulative frequency is to, for the first group, which is for in this case now is 0 per 0, there are 50 of them. I'm talking of the column of a brown color now. So the next one, which is para 1, how many of them? You know there are 11. We now add the 11 to 15, it gives you 26. That's cumulative. You are accumulating it. Then the next one, para 2, there are 8. You add the 8 to 26, it gives you 34. Para 3, there are 6. You add the 6 to 34, it gives you 40. Para 4, there are 5. You add the 5 to 40, it gives you 45. Para 5 is 5. You add the 5 to 45, it gives you 50. If you remember, the total for this, they are 50. So you are adding in that, if you have arranged in ascending order, you begin to add the subsequent frequency of the subsequent level to the former one, just to be. So at the end of the day, it cannot go beyond the total. So, of course, you have not expressed it as percentage, just the value. So for you to express it as percentage, just like what we did for frequency, relative frequency, you now put cumulative relative frequency. You express a percentage also. That's the last column. That is why the 4 type of distribution we have is frequency distribution, relative frequency distribution, cumulative frequency distribution, cumulative relative frequency distribution. So what relative frequency distribution does to frequency distribution is what cumulative relative frequency distribution does to cumulative frequency distribution. That is, you just express a percentage. So this issue of cumulative now, what is the usefulness of it? Why do you want to use it? You use it in a situation when you want to say how much, at least how many are, for example, now I want to say how many are and what proportion of these women have at least para 3, at least. Okay, let's start with at most para 2. At most, if it's at most para 2, mean that it can be 0, it can be 1, it can be 2. So if you look at cumulative frequency, the way we accumulate up to that level, para 2 is 68%. So 68% are at least, at most para 2. But if you say at least para 3, so if you read at least para 3, that is, it can be 3, 4, 5. In that situation, you cannot say you are adding 80. No. So what you do now, where does this start? where did it end before it started? So if you before you start, the two ended with 68%. So if you want it at least 68% for at most 2, you remove it from 100, it give you what? It give you 32%. So the percentage for at least 3 will be 32%. If we say at least 4 is 20%, at least for me, either 4 or 5. And if you are removing up to 3, is up to 80%. So if you remove 80 from 100 because the total is 100%, you know that the remaining is 20. So at least 4 is 20%. So I don't know if you have questions, you can chat or raise hand so that I can clarify. So yes, you have understanding of the different type of distribution. Now, let's talk about how do you display distribution. We have just talked about different type of distribution. So remember, we are in descriptive statistics. We are trying to describe the data. The first concept is distribution. That's why when you're analyzing or you need to tabulate, you can put the frequency, you say frequency table. That's it. That's why they talk about frequency table. You are trying to do the distribution. So how do you display the distribution? You are doing your analysis. How to display it? The first one we just did now on the table is just tabular. That's number, the simplest way. Tabular distribution, shade on table. And that's what many people are used to. Just put table age, group, sex, you say male, 52%, female, 48%. You are finished with that. You go to ethnicity, you go. So that is tabular form. So 2 ways of displaying distribution: tabular form, frequency table, which is what we have just shown now. Then we also have graphical. That is, you can use graph. So the tabular form, simpler, you have seen it, we are used to it, but let's look at the graphical form. This graphical form, the type of graph you do depends on the type of data you are dealing with. Now, the graphical form, there are 2, the graph you use are divided into 2. We are not saying, when we say displaying distribution, graphical, there are some other graph in statistics that is not distribution you are displaying. You may be displaying relationship between variables, like for example, a scatter graph for correlation now and regression. It's scatter graph. So in that situation, you are not displaying distribution, you are looking at relationship. But we are talking of graphical form of displaying distribution. And there are 2 groups of this graphical form. You can see one group. We have example there, pie chart, bar chart. We have other group. We have histogram, stem and leaf plot, box and whisker plot, frequency polygon, cumulative frequency polygon, we also call OGI graph. Now, this one, pie chart and bar chart, is usually for discrete data, while all these other ones are for continuous data. If you remember yesterday, when we were talking about the type of variable, I said, I first of all give the most fundamental approach, numerical and categorical. Under numerical, you now have nominal, ordinal. Under categorical, you have nominal, ordinal. Under numerical, you now have discrete and continuous. Remember, and I'll give you another alternative classification where you just say, okay, variable is divided, is either discrete or continuous. We now say is under the discrete, you have the nominal, ordinal, and numerical discrete. So the discrete you put under the numerical before is what come under numerical, you now call numerical discrete. So, and I told you that method make more statistical sense. Yeah, that's what you are seeing here now. So whenever there are the variable that are discrete, for example now, nominal, ordinal, and discrete numerical, you use pie chart or bar chart. But if it is continuous variable, you use histogram or stem and leaf plot, box and whisker, frequency polygon, cumulative frequency polygon, or OGI. Now, let's look at pie chart. In what situation do you have to use the pie chart? We know that, yes, it's for pie chart and bar chart, is for discrete. But It's not the situation. You pie chart and bar chart are used in different contexts also. For example, pie chart, you can see now is like pie. So it's like a circle. So the area under the circle, the sector, is all. Here now we have two possible values. This is for a group of people you study that have diabetes, no complication. The red section, the people with no complication, this one complication. So you can see 51.5% have complication, 48.5% do not have complication. So you just show it in pie chart like that. If there are three categories now, the utility sector. So can you see? So this type of chart is used in a situation when you have mutually exclusive variable. For example, sex is mutually exclusive. You either male or female. The meaning of mutually exclusive is that if you belong to one category, you cannot belong to the other category. So if ethnicity, you have to choose from either Hausa, Igbo, Yoruba, or others. In education, level of education, either no formal, primary, secondary, or tertiary, or whichever way you do it. In that situation that is mutually exclusive, if somebody is classified as primary education, the person cannot be classified as secondary education. So at the end of the day, everything we added to 100%. So we've got, because the sector, the area or this the angle of a cycle of this pi is 360. So it cannot be more than 360. But in a situation where the what do I call it talking about, the variable is not mutually exclusive, like independent. For example, yesterday when we were doing our SPSS session, we talked about symptoms. Symptoms is not, when you say what are the symptoms of woman cervical cancer, I would say dyspareunia, pain during intercourse, then bleeding, discharge, now, foul smelling smell. So all those things are different symptoms or whatever. Now, for the fact that somebody have pain does not preclude the person from having discharge. Does not. So somebody can have all the symptoms at the same time, or one of them, or two of them, or three. Any of the three of them, any of the four of them, any of the two of them, any of them. So that's when you, or if it is knowledge you want to elicit, you know what are the symptoms of cervical cancer. The person that know that pain is a symptom may also know that discharge is a symptom, bleeding is a symptom. So in that situation, when they are taking, they will take as many. In your questionnaire, you say take as many as appropriate. That is, symptom is the variable, but different value of that variable. Many people may choose many of them at the same time. So if you are trying to now add the total that choose all, it will be more than 100%. Therefore, if your sample is 300, and some people are choosing up to 3, when you are adding everything together, it may give you over 700, because they are independent. They are not mutually exclusive. Like if somebody chooses this one, it doesn't mean that I cannot choose this one. So it is only when, if you belong to one group, you cannot belong to that. That's mutually exclusive. But when it is independent, you cannot use pie chart. Can you see that? So for symptom now, you cannot use pie chart to display symptom, because there are many symptoms for that thing, and somebody may have more than one of them, or the knowledge of it. Somebody may know more than one of them. So this example you are seeing here now, we are using bar chart for. It's an example of independent where you cannot use pie chart. So here now, we are talking of the treatment modality for diabetes. Somebody may be on diet and exercise together. In fact, one may even be on diet alone or exercise alone. Most of the time, okay, let's say diet and exercise together. Someone may be on oral hypoglycemic agent, that is the tablet that lower blood sugar. Somebody may be on insulin, it's an injection that lower blood sugar. Now, somebody may be on diet and insulin at the same time. Someone may be on diet and oral hypoglycemia at the same time. Some may be on insulin and oral hypoglycemia at the same time. Some may even be on the three of them. Can you see now? So it's not mutually exclusive. This treatment modality is not mutually exclusive. If you there's no way you can put it in a pie chart. For example, now look at Out of this, 39% on diet and exercise, 81% on oral hypoglycemic agent, 30.8% on insulin. If you add them together now, it's 100 over 100. 39 plus 81 is already over 100. Can you see? It's already 120. That one's already 120. We now had 30.8, making 150.8. So it's usually above the total 100. You cannot add it. That's why you should, because the logic behind it is that there are this, when you see oral hypoglycemic agent, 81, that shows that there are some people that are oral hypoglycemic agent, they may be on diet also, or some may be on insulin. So you just did for each of them, knowing that there will be some overlap. This is when you use bar chart. You can also use bar chart too if it is mutually exclusive. Yeah, even for the complication of population, you can use bar chart. But you cannot use bar chart for this issue of independence. So that's that bar chart can be used for both mutually exclusive and independent. But bar chart can only be used for mutually exclusive, cannot be used for independent situation. Now, let's now move to the continuous variable, those ones that are not discrete. What are the, we have different, this histogram. This histogram now, if you look at it, it looks like bar chart. But the only difference is that there's no gap. If you look at the bar chart we did before, true, there are gaps in between these. But here, they are lumped together. The reason being that there's no sharp boundary between value and continuous variable. We have already said that for discrete variable, imagine if they say number of, or what you say, sex of the variable or sex of your participant. Is either male or female. So they are discrete. You can plot their graph separately like this one. If they say ethnicity, you can plot the graph up to about 4 or 5 different bar charts for it. If they say even number of children, you can plot the graph from maybe 1, 2, 3, 4, 5, 6. You can plot separate graph. But because you cannot have 1.5, 2.5 children. But when it comes to blood sugar, for example, you can have blood sugar of 60, 60.0001, 0.002. So you cannot say you plot the graph of 60 and 61 because it's a continuous. That's why they clump together. Because it's a continuous level, the graph are no, there's no space. Now, you will see the shape now. We'll get to talk about that when we get to probability distribution. This is a normal, this is what we call, you want to look like normal distribution, you go up and come down. But just leave that one, just look at the shape. Look at this one, stem and leaf. This stem and leaf, you will see that it's the same shape as this. It's only that this stem and leaf is sitting on the side. It's like you put a bottle, put it by the side. It's lying on the side. If you look at it now, it goes up. If you go up like that, come down. So it's the same. In fact, it's the same data set, exactly the same thing. I used to plot the two. You know, the same thing I say, plot histogram, plot stem and leaf. I used to plot. So it's the same thing. The only difference is that this stem and leaf give more information than histogram. Because if you publish this in a journal now, histogram just show you the shape. But if you stem and leaf, the person reading your journal has access to the data set for that variable. You can copy it out. So what do I mean? Look at this now. This is weight of some women that came for antenatal in one clinic. This weight of these women, nobody has up to 100 kg, but we know that it's 2 digits. So stem and leaf, what it does is it will plot the last digit as the leaf. The initial digit as the stem. But because this one now, we are talking of weight, and there are only 2 digits for this weight. Say that you are 76, 78, 80, something like that. So 65, 60. So there is no 100 or something. So there are 2 digits. So the second digit is the leaf. The first digit is the stem. If we are talking about height in whether centimeter or meter, you usually have 3 digits. I say 1.56, 1.72. That last digit, 0.07, that last digit will be the leaf. The first two digits will be the stem. Then let me tell you now for this weight now. What you are seeing here is, can you see the first column is the frequency. The other one, you are seeing the stem and leaf. So for the first school now, you see frequency 2, that is, there are 2 in this category. And the stem is 5. And the leaf are 7 and 9. This is 57, 59. There are 2 people. One weigh 57, the other one weigh 59. This one, there are 7 people. The second row, there are 7 people in this category. In the second row, 60, 60, 60, 62, 62, 63, 63. That. So 7 of them, 3 of them, 60, 60, 60. That 6 is the stem, while the other one are just the leaf. So 60, 60, 60, 62, 62, 63, 63. So the third one, there are 9 of them, 65, 66, 67, 67, 68, 68, 68, 68, 69. This one, there are 30 of them like that. I don't know if you have questions concerning that stem and leaf. Do you understand it now? The way I've said it, you should be able to pick it. If you don't have, you can shout or raise your hand. If you have questions, you don't understand the stem and leaf. So that is the way you plot. So somebody can carry Biro now and begin to copy everything. Copy the weight out. Because even if the person publishes in the journal, you can copy it out and go and enter into the computer and run the analysis with that variable. Because you have access to that data set. That's stem and leaf for you. If there's any question, let me know. Then, and you know, both of them are just used for continuous variable. Another one they use for continuous variable is the box and whisker. In this box and whisker now, the box, you will see box. You will see a line in the middle of the box. You now see some line, which they call whisker. Sorry. Whisker. You know, the whisker of a mouse, of a rat, you know. So the line in the middle is the median. The lower part of the box is the, anyway, we have not, I know it may find it difficult to understand. Maybe I should leave it now, because we are going to talk about how do you summarize this summarizing quantitative variable, continuous variable especially. One of the things we are going to discuss is how you summarize percentile, all those stuff. So you may find it difficult, but just know that we can come back to it. The middle is the median. The lower part of the box is 25 percentile, the first quarter. The upper part of the box is second quarter. The end of the lower part of the whisker is the lowest value. The upper part of the whisker, or this upper part, is highest value. We'll talk about it later. Now, let's look at frequency polygon. So this frequency polygon, if you look at the histogram, can you see the way it goes? Instead of, you know, for you to, if you join the middle of each of the bar of the histogram, it gives you the frequency polygon. So the frequency polygon we are looking at is this red. Can you see now? You can see the other line graph is the bar histogram. So we join the middle, that it gives you that shape. That red shape is the frequency polygon. Now, is a way. If you look at it, it's the same way. It's just different way of displaying continuous variable. Then you see cumulative frequency polygon, or OGI. If you remember, when we talk about frequency, we talk about cumulative frequency. So that cumulative, if you remember, you are adding each group, each step. If you are arranging ascending order, as you are going higher, you are adding each frequency to the previous one, so that it will not go back. It just go up to give you the highest value, the total frequency. So look at this frequency polygon now. Sorry. When you reach this one, the peak of the graph, instead of you, instead of you to be showing each level, each bar, you are adding it to the previous one, or it will go up. That's what has happened. So it just go up. They usually give this sigma shape. It will first go slowly and slope suddenly and now go slowly. This is what we call sigma shape. This is the frequency polygon. So there's not a big deal. It's just playing with data set to display the frequency, different way to display frequency. I don't know if you have any question concerning different way of displaying this frequency. So we have talked about frequency. Yeah, how do you display? Talk about tabular, graphical. The graphical is the one you method partial and partial you use for discrete data, and all these other one, histogram, stem and leaf, burst and whisker, frequency polygon, cumulative frequency polygon, which is Auger graph. Those are the methods. So now let's look at how do you summarize data. If you have question, you can raise your hand or chat. So before we move further. So how do you summarize this? Remember, we are still in descriptive statistics. We are talking about frequency distribution now, and how you display. But how do you summarize? That's display. But how do you summarize the data? The way you summarize data depends on the type of data. You know, we have already grossly classified into qualitative and quantitative. Qualitative or categorical, and quantitative, which is numerical. Mind you, I want to sound a note of, I want to bring your attention to something. The word qualitative data, quantitative data may mean different things in different contexts. In this context now, we say quantitative data mean the data we get from variable like sex, ethnicity, marital status. Naturally, they are non-number. Just call it categorical. While quantitative are the data we got for age, number of children, anything that has something to do with number, weight, height, blood sugar, that's quantitative data. You know, quantitative variable, quantitative data, qualitative variable, qualitative data. But when we talk about approach to research, you remember, okay, it's not you, because it's not your set as taught research methodology. It's the set before you. I taught research methodology. I told them that the approach to research was a qualitative and quantitative. Quantitative just means that you are using like survey, something questionnaire where you're going to use statistics, the commonest one, you know. But qualitative here is in word. You do focus group discussion, key informant interview, in-depth interview. So the word quantitative and qualitative came for those research approaches based on how you summarize the result. You know, at the end of the day, for the survey, the one you use questionnaire, you are going to summarize with number. This is the percentage, this is the mean, this is the mode, median, this is proportion percentage. Either mean, mode, median, yeah. So you're going to see later now the mean, mode, median for quantitative, the percentage for qualitative. But the whole number, if you say 55% is number, that's for any result that requires a questionnaire. That's how you summarize it, because the summary is in number, and that's a quantitative research or quantitative approach. Then why the other one? Because the summary is in what? You are not going to say 55% say this in a focus group. You say, you quote, you just say some of them. You know, you now summarize that these are the various modality, what are the factor, the barrier to utilization of health services. One of them is lack of transportation. You now call somebody that, this place, so we don't even, there's no car. The problem here, some people say, the thing is too expensive. You now say, oh, affordability, poverty, that is they don't have money, lack of money. So all those things you quote to support. You don't summarize, that's why they call it qualitative research, because the result is just a word also. So if you collect your data, that data you collected for research, from questionnaire, they call it quantitative data. The data you collect is quantitative data. The voice you recorded for focus group discussion, key informal interview, they call it quantitative data. Can you see now? So that one is different. Here now we are talking of statistics. We are talking of quantitative research. In this quantitative research now, the variable that have number originally, we call them quantitative variable, and the value are data, quantitative data. While the one that have no number, value has no number, like sex, ethnicity, those one they are qualitative variable, and the data quantitative data. That's the context we are talking here. So summarization of qualitative, that is, we are dealing with issue of things that have no numerical value before, like the type of treatment you get, is this chemotherapy or radiotherapy or surgery or whatever. The ward, are you in medical ward, surgical ward? Which department do you belong? What's your profession? Those are the things. What's your ethnicity? These are categorical variables. How do you summarize them? Since they don't come in number, I mean issue. So what you do is what we call ratio. So if you remember the more ratio, if you did physics, you remember that the ratio is what you get when you divide two quantities of the same unit. Two quantities of the same unit. For example, now, if you say somebody travel 100 kilometers, another travel 400 kilometers, you want to compare the two. You say 400 over 100 is 4. You are trying to say that this person has traveled 400 kilometers has traveled 4 times than the person that traveled 100 kilometers. So if you divide 400 kilometers by 100 kilometers, it's not 4 kilometers, it's just 4. Because kilometer has cancelled out kilometer, just 4. But if you say somebody travel 400 kilometers in 4 hours, and you now say 400 kilometers divided by 4 hours, it gives you the speed or the velocity, it's very not the least interest. So 400 all over 4, making 100 kilometers per hour. It's not just 100, it's 100 because the denominator is in kilometer, the numerator is in hour. So the answer is in kilometer per hour. That one is not a ratio because you are in that, you are not divided two things of the same unit. But when you say 400 over 400 kilometers over 100 kilometers, is a ratio. When you divide two quantities of the same unit, so the result will not have unit again. The unit has cancelled out. It's just a value, it's dimensionless. That is, you cannot say kilometer, you cannot say second, you cannot say kilogram, you cannot say anything. It's just the value. Does it make sense? So the logic behind it is that when you are summarizing the particular variable, for example, sex, the categories there are male and female, and both of them are human beings. So when you say, you may decide to say, okay, how many women do you have? Like, for example, in this case, maybe we are 50. We now say we have 40 women. How many men? 10 women, 10 men. 40 over 10, 4. That it shows that women are 4 in the times number than men. It's just 4. It's not 4 women, men, whatever, over women over men. No, it's 4 because you are the same human being, the same unit. You just, that is the ratio. So that is the logic of summarizing the qualitative data, because each of, is categorical. When you look at the ethnicity now, Hausa, Igbo, Yoruba, other, how many in each category? How do you want to summarize it? I mean, it's okay. I mean, if you begin to decide, maybe Hausa is the major number in there. Now, Hausa divided by the rest. What does it get? Divided by Igbo, divided by Yoruba, divided by how many times are they more? You may be doing that. You are trying to do ratio. But the commonest one is what we call proportion. So, in ratio now, the numerator and denominator is not the same. That's ratio. It's not part of. For example, when I say male-female ratio, female-male ratio, 40 female over 10 male. The 40 female, they are separate. They are not part of the 10 male. But there are some situations where the numerator is special form of ratio. When the numerator is part of the denominator, for example, now, I want to know in among this 50 class, we not say what proportion of female? 40 female over total, which is 50. You know that total 50, those 40 female are still part of the total 50. Because that total 50 that is serving as denominator is 40 female plus 10 male. But you not say 40 over 50. That is proportion. It's a special form of ratio in which the numerator is part of the denominator. We now say, okay, the proportion of women here is 40 over 50. When you divide it, you give it 4 over 5. You cannot say 0. In that situation, you do it, give you 80%, 0.8. If you solve it, 5 over 4, you will 0.4 over, sorry, yes, 4 over 5 rather, 4 over 5, it gives you 0.8. Then for the male, you now say 10 over 50, which is 1 over 5, it gives you 0.2. Can you see now? So the proportion, but because most of the time, when you say 0.2, many people don't understand. 0.2 means 20%. So if you now express as percentage, just like what you just times 100, it gives you 20%. It's easy for people to understand percentage. If you say, what are we looking at? The proportion that I came to women that are in the class that are just 0.85. So some people that don't have statistical mind or manual, they look at, what do you mean? You say 80%. Oh, is it 80%? You are saying 85%. Oh, I understand. Because people know out of 100, 85%. So when you express in decimal, so both the in decimal and percentage is proportion. It's only one is in decimal, one is percentage. So sometimes when you say percentage, it's the same thing as proportion. So proportional is a special form of ratio. You are dividing two things of the same unit, but the numerator is still part of the denominator. That's proportion. Now, another special form of proportion is when that what you do is over time, maybe over 1 month, over 1 week, over 2 days, over 1 year. Most of the time, some of the indices we measure in our health indices over 1 year. All this maternal mortality ratio rate, infant mortality rate, all those things, underfant mortality rate, we do it over 1 year. So that's why we call it rate. When you calculate that thing, what you calculate, the data is gathered over a period of time. It's not just one point in time. Over a period of time, it is called rate. So when proportion is over a period of time, it's rate. So can you see rate, ratio, and proportional? So all of them are actually ratio, but the special form of ratio where the numerator is part of the denominator is proportion, and the special form of proportion where time is included is rate. That's what you can see here. You can see the flow chart here. Ratio is the numerator included denominator. If it is no, you see as ratio, normal ratio. Then if it is here, you say it's proportion. But even in that proportion, is the time included in the denominator? If time is not included, it's proportion. If time is included, it's rate. And you see now, the funny thing about the proportion and rate is the same calculation. There's nothing. It's just the time. For the fact that I did it, it's not as if the time you will include in the calculation. You will not, the element of time will not be in calculation, but because the data was gathered over a time, you are measuring that over a period of time. That's what makes it rate. But of course, the ratio is, you know that numerator is not part of the denominator for the pure ratio. But the special form of ratio where numerator is part of the denominator is proportion or rate. Proportion means the time is not part of it in calculation. Rate, time is part of it. So example is maternal mortality ratio. Who can differentiate? We usually ask people. Even I'm sure some of the, even you are finishing page now. We have, even I discuss it with you, some of you cannot see differentiate between maternal mortality ratio and maternal mortality rate. So maternal mortality ratio is number, you are calculating it, number of deaths among women of reproductive age over the total number of live births. Can you see now? Number of deaths due to pregnancy or pregnancy-related childbirth and pregnancy, due to pregnancy and childbirth, over the total number of live births. In that situation, you remember the numerator is the number of women. Women are different from children. The live birth is denominator. So if you look at it, the numerator and they are different. That's why they call ratio. But when you say maternal mortality rate, number of women that die over total number in the reproductive age group. If you look at it, the denominator, which is total number of women in reproductive age group, capture the denominator, numerator also. So in that situation, the numerator is part of the numerator. That's why for maternal mortality rate. Can you see the difference? So many people cannot, even that are doing NGO work, that are doing, they cannot differentiate. I've met a lot that cannot differentiate. I'm sure some of you here now you are doing, you cannot differentiate. So just get it clear. Now, we have talked about how you summarize qualitative data. Now, this one, the most important here, if you agree with the proportion, because that's where you use your percentage, you tabulate. The most of the time, when you do all the tabulation, is percentage proportion. But once in a while, you say male-female ratio, all those sort of do it. The proportion is majorly. Then let's look at how you summarize quantitative variable. That is quantitative data. You know, this quantitative data is quite different from the categorical in the sense that, you know, in the categorical now, we have already said that there are manageable number of categories. For example, if you say religion, Christianity, Islam, traditional, you have 3 categories most of the time. Even most of the time, even in Nigeria, you may not even see, when you do your study, you may not even see those traditional, either Christian or Islam, Christians or Islam. You see, it's easy for you to, okay, how many are Christian, how many are Muslim, and you tabulate. But when you talk about, let's say, weight, if you measure 400 people's weight, if care is not taken, all of them may have different value. You may not even have one that coincide. It's only on few occasions you can see some few that are the same value. All of them will have different value. So it's difficult. How many categories will you give? Say, okay, this would have this. So we have plenty value to deal with. So intelligent people now came with the idea of these 4 ways of summarizing quantitative data. The first group is measure of central tendency. In situation where they are looking for one value that will represent the whole. That will represent, you just say it, like mean, what is the mean? You know, represent all of them. That's why that value must be something close to the center, that is more like average. That's where we got the measure of central tendency from. Or it's also called measure of location. Measure of dispersion, that is, I will explain it. It's not enough for you, okay, you may have one value, but there are some value that are close, there are some data set where value are close together. For example, now, if you measure weight and height, weight will spread more than height because the values of height among human beings are not too different. The value are not too different. But weight usually have extreme weight. Some people that are very obese, some people that are very emaciated are don't weigh much. So the spread of weight is much more naturally than height. So there are some variables that they don't vary much in the population, while some vary a lot. Can you see? Now, we have also measure of relative position. In this one now, we're going to talk about all of them. That is, this one is even simple to understand. If you remember when we were in primary school, secondary school, the same thing, you have your kids. It's not enough to say this is what you score. In the class, many of you 40, which position are you? Are you number 1 or number last? Anybody, even if somebody score 90%, so far it's close to you still beat the person. Okay? So you only beat only one person. However, the person has done well. Maybe they are very good in the class. But the issue is that it's the position. So we'll talk about it. The measure of distribution shape. This measure of distribution shape is not far from this number 2. How spread the value naturally. So let's quickly run through each of them. Mean, I will not waste time, is the average, many entry average number. That is, If you add all the value together, divide by the total number, the sample size, it gives you the mean. So sometimes we write formula sigma, mean in bar X. We already said it in our when we were discussing parameter and statistics. We said the statistics are denoted by Roman alphabet, like bar X. Mean is bar X. No, mean is summarization. You want to summarize, you add everything together, you divide by the total number. So sigma mean addition. This one that look like E. This sigma. Addition of all the X over the sample size N. That's it. Then when we talk about group data, though for statistical, for mental exercise, well, we still talk about group data, but it's usually with the computer now. Well, concern computer, if you have millions of the computer will run it for you. So you don't need to use hand to run it. So the idea of this group data, me, I don't fancy it. Me, I cannot even give you to, I don't like setting this type of question, even for people in exam. They come and do group data. For what? Exercise a facility. So it's just for you to understand the logic behind it. The logic behind it is that you know that in each group, when you put a value, there are many frequent. How many frequencies? So you now multiply the frequency by the number, divide by. Just leave that one. So just know that mean. These are the advantages and disadvantages. I will not waste my time with all this work because you know them are very simple to calculate mean. Used for further statistical calculation. Mean is the most useful when it comes to advanced statistics. Let me tell you something about statistics. Once you can understand the logic behind this mean and standard deviation, and this is your sample size standard, you discover that advanced statistics, it's very simple, very simple. In advanced statistics, just they play around mean, standard deviation, variance, all those things they are playing around. Most of them, even the median and mode, they don't usually feature. Most of them is only for a few occasions. But it's about mean, standard deviation, sample size, variance. That's all. You will see. Now, that's why mean is used for further statistical calculation. All the value in the data are taken into consideration. So therefore, it's representative than mode and median. Then relatively reliable because it does not vary much when repeated samples are taken. So if you take, unlike mode, now if you take the mode, may change easily, median may change easily. Because mean we still bring everything together and divide, so it doesn't change much. But it takes longer time to calculate. It's not as simple as the other one, not easily understood by non-statistician. You're going to know the reason. Imagine I say number of children. You now say mean number of children 2.5. You know that 2.5 number of children cannot be even 2.5. Is we have already said it's a discrete variable 2, 3, 4. You cannot say 2.3 number of children. But the mean, when you calculate the mean, it give you. So it doesn't make sense to, how can you say the mean number of children 2.5? But the mean will give you because that is the way it is, because you had everything together. Even if your original error does not have decimal, by the time you calculate, you divide by the number, it may have decimal. Then does not always represent actual score belonging to some member of it. It's the same thing I'm now saying. 2.5, but no number of children is actually 2.5 or 2.3. When used with discrete variable, is often used all realistic value. Still to say the same thing, then affected by extreme outlier. So we'll talk about outlier later. So this is mode, a mode. Most, so if you look at it, most often the one that appear most is the mode. You will know when you see the frequency, you know. But in group data, it's going to be difficult for you to know if it's group data, to know the mode. You can only know by spotting. You look at the modal group, the group that has the mode, but you won't be able to know the value. You need to use all those rigorous calculations. This is a formula. This one is just there for academic purpose. Don't bother yourself. And the advantage, don't let me waste my time. You discover that disadvantages of mean will be the advantage of mode and median, and vice versa. So middle value is the median. It's the same thing. If you arrange the value in ascending or descending order, the middle one is median. You can only get one value if the total number is odd. But if it is even, it's going to be two values that be in the middle. You calculate the average. You add the two together and divide by 2. So for group data, it gives you this type of headache. This formula. Don't bother yourself. So let's just move. Geometric mean, just leave that one. Let's move. This is an example. We have talked about measure of central tendency now, location. Let's talk about measure of dispersion, R spread. So the different type, we have range, median, variance, standard deviation. Range. So before we move further to do that, let me just give you a scenario. Why do you want to know after you have known measure of central tendency? If you have question, raise your hand or chat. Why do you even want to know measure of spread? The reason is very simple. It has been discovered that measure of central tendency, mean, mode, or median, is not sufficient to describe data set. Let me give you an example. If in this class now you did 8 subjects and courses, I call it courses, and we want to get the best, at the end of the day, the best student, you try to calculate the average. If, let's say, 2 people got 85 as average, or let's say 80 as average score, 80. And who is the best among them? You don't know yet, unless you try to use another modality. In that situation now, you have, okay, this person get 80. You look at what are those values of each subject. 80 is the average score. But for each of these 8 subjects, the person may get 100 in one, 99 in one, and 45, or even 20 in another one. So the variation is much. It score high extremely in some, score low for something in some, and average is still 80. Whereas another person whose average is 80, maybe the value are 82, 79, 85, 74, the value is around that 80. The average is 80. So because it doesn't spread much, you consider it to be better than the person that has extreme value. Score very low, score very high. They still have the same average. Can you see now? So measure of central tendency will not tell you. It's just like if you have a clinic now, somebody you discover that the average systolic blood pressure of the people coming to your clinic is 110 millimeters of mercury. Another friend of yours said, in my own something is 110 also. Does it mean that the distribution of blood pressure is the same among the people that come to the 2 different clinics? It may not be it may not be the same. It may be the example I just gave now. Maybe in one clinic, the average is 110, but we have a lot of people that have 150, 160. I also have extreme value 90, 80, or less than 97. Why in some, the average is 110, you are using 120, 115, 92, 93, 113. The value is still another one. So that is why the measure of central tendency does not tell you how spread the value are, and that's why we want to do. These are the measure of central spread or dispersion. They call it measure of spread or dispersion. Range is the smallest minus the highest. That is, you remove the smallest from the highest. So, or you range from smallest to the highest. So range is simple to calculate. What's the highest value? If it's weight, you are looking, who weight highest, who weight lowest, you remove it. That's the range. But that one is very funny. It can change anyhow, especially if you the more the sample size, the more the range, because the more the sample size, the more probability you're going to have someone that has very high score and someone that has low score, and make the range to be wide. So deviation. So this one, don't let me break my tongue. Deviation, variance, standard deviation. It's better used example. So I usually use this example I put here, which I have discussed with you before. Now, let's see quickly, so that we quickly round up and do our practical session. So let's assume that this value you have here. You have, let's say, we have 5 people. We want to know the number of seconds it takes them to read a passage. small passage, number of seconds take them to read a passage, or maybe some sentence in a passage, or just to even trek across a particular short distance. There's a number of seconds it takes to move across a place for each of them. Let's say the first one, you will now arrange it in ascending order. The first one is 3 seconds, 4, 5, 6, 7. So when you add all the value together, it gives you 25. So if you want to know the average now, the average here is 25 over 5 because there are 5 people. It gives you 5. That is the mean. Now, we want to know the number, we want to know this is a measure of central tendency. The mean, the measure of dispersion now, how far apart are the value? If it's range now would be 7 minus 3. Range is 4 because the highest is 7, the smallest is 3. The range now is 4. Range from 3 to 7. Now, the deviation, that is, each of them, how do they differ from the mean? What's the distance from the mean? So the mean is 5. So what you can do now is to remove mean, as you arrange them in ascending order, remove mean from each of them. So the first one now, this second column now, deviation from the mean. So you know that the initial one that are less than the mean, when you remove mean, it gives you negative. So 3 minus 5 is give you minus 2. 4 minus 5 give you minus 1. 5 minus 5 is equal to 0. 6 minus 5, 1. 7 minus 5, 2. And you see, it starts from 0 in minus and pass through 0. If you pass through 0, if there is some value that equal to the mean, when you remove mean, to be 0, the difference with the deviation with 0. You know the funniest thing with the deviation? It's just like you ask them to line along, let's say, line up and be facing you. So the middle person is the one that has 5. So on the right side, this one that has 6. Then to the right of that side, this one that has 7. To the left side, this one that has minus, that have 4. To the left of that one, 3. So it's just you are looking at the distance from the mean. So because some have negative, some have positive, if you try to add the deviation together, it gives you 0. Some of the deviation, that is, if you look at it, sigma, x minus x bar. X minus x bar is the deviation. Some of it is 0. It's always like that. So it's useless. You cannot move further. It's 0. 0. So the intelligent people, that's okay. What do we do? Then that's okay. Let's square the deviation. When you square the deviation, mathematically, you know what is the implication. The negative goes out. So now, when you square minus 2, give you 4. Minus 1 give you 1. Okay. So can you see now? Those ones that have minus before, they are not look like the other one that don't have minus. So you cannot add it together. So what you have added together now is the distance from both sides. That is, you square it. More like you amplify it. You just need to do that because you know that if you don't do that, you add it together, it give you 0. So, but when you have amplified now, remove the negativity, they give you the total square of the distance, square deviation from the mean. This is what we call mean square deviation. Mean square. You've added it. By the time we get to ANOVA and regression, you go to see mean square. So mean square deviation from the mean. That's what you have now. Total. If you look at the total, sigma x minus x bar square. That's mean square deviation. The problem with the mean square deviation is that so it's going to be, it's not an average because the value you get will depend on the sample. Just like the total value, this 25 you have there, when you add all the heads together, if the sample size, there are plenty, more than 5 people, it will be more than that. But that's why you are not interested in, that's why you calculated the mean. The same thing here. The mean square deviation from the mean is, the value will depend on the sample size. So how do you calculate the average? This average square deviation, average square deviation from the mean. Average square deviation from the mean, not mean square deviation. Average square deviation from the mean. Or square deviation from the mean, the total. If you want to, you now calculate the average. Calculate it now. How do you do it? Instead of you using here, when you calculate average of the total number, 25 over 5, you use sample size. But here you use what we call degree of freedom. The degree of freedom, the concept. Let me just quickly explain the concept of the degree of freedom. The degree of freedom, what it just means is that what is the, how many out of the entity you are dealing with, how many of them can vary their value? I usually use example if I teach physically in the class. I will just ask, I can ask 5 people to come and sit down. I arrange 5 shares for you. You are having a meeting. The first person we choose between the 5 shares. You say the first person has choice to choose between 5 shares. The second person has choice to choose between 4 shares. The third person that will arrive will have choice to choose between 3 shares. The fourth person arrives have choice to choose between 2 shares. The last person does not have choice. It's only 1 share that remains. He just has to sit. He cannot say, this lawyer, I don't like his pen. He has to sit. He doesn't have choice. So for the fact that out of the 5, only 4 can vary, it's not the number of choices that matter, but can decide that I will do this, I will not use this share. Can vary the share they can see. That is the degree of freedom. That last person cannot vary. Can you see now? That is the logic. So it's the same thing here. If you say we have score, the total score here you have it 20. Maybe we have money, or you have let's say you have apple at home. You have 5 people in the house, and they put 20 apple there. It's 20 apple, no more than that. Can you see? Number 1 ahead 6 apple. Number 1 number 2 came. He can decide to hit more. That number 1 can decide to hit 8. That's more than 20 apple has not finished. Can vary any apple he can hit. Can even hit 1. Can decide to it's not eating anyway. The next person can vary also. The same thing. But that last person, after all of them have picked 6, 4, 2, 5, it remains 3 apples. So that one, it doesn't have choice. Everybody has it into your own that remain. Whatever is that 3 that made that. So the degree of freedom is 4 because out of the 5 of them, only 4 can vary how many apples they will take. That is why the degree of freedom is 4. And the logic behind why the concept of degree of freedom is very simple here. Then when we get to different statistics, it's the same way, but in a different way. It's the same thing, but in a different way. But here now, I just want you to, the logic behind it is that in the population, the variable, let's for example, weight of adults vary. Some of you lose your weight now, you gain it. As you lose weight, some people lose weight, some people will gain weight. The issue is that weight among adults, variable itself, the value vary all the time. Even your weight, the last month is not your weight now. It varies. But over a period of time, the average weight remains constant in the population. The average weight remains constant. So the issue there is that if you have calculated the mean, because when you calculate the mean now, you can multiply the mean times the total number. It gives you the total number of that value in the population. And it's not more than that. It cannot be more than that. So if anybody is very, 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 there are some entities that cannot vary. That is what the logic behind this degree of freedom stuff. Here now, that is why when you are now, because you have already used mean to calculate up to square, when you were calculating mean, you divide by 5. You have not calculated mean before. But now, for you to get deviation, standard square deviation from the mean, you have already used that mean, and mean already fits the whole thing. So in this place now, all these entities cannot vary. Only 4 out of 5 can vary on their own. So because of that, when you want to calculate the average square deviation from the mean, you cannot use 5, you use n minus 1, which is the degree of freedom. So when this one now, which is 10 over n minus 1, is 10 over 4, make it 2.5. This is the square deviation, average square deviation from the mean. That is, you square deviation, average of it. That is, for each of them, averagely, what is the square deviation? But the problem with this is what we call variance, as average square deviation from the mean. Now, if you understand this concept now, when you say formula of variance, it's not difficult to write. You don't know climbing. So sigma x minus s bar square over n minus 1. And you see now, it's sum of square deviation from the mean over degree of freedom. Now, the problem with variance is that the variance, it gives you 2.5 seconds. We already calculate average second they will use is 5 seconds. The plus or minus 2.5 seconds square. Because this one has square, because it's a square, the unit is square, second square. Because if you remember, you have squared the difference. So in order for the unit of the measure of dispersion to be the same as the unit of measure of center tendency, which is the mean. What is the, you square before, what is the opposite of square? You calculate the square root. If you calculate the square root, it gives you the standard deviation. So standard deviation is square root of variance. Whilst variance is square of standard deviation. So variance and standard deviation like water and ice block. If you have ice block, you need water, you melt it. If you have water, you need ice block, you block it, you freeze it. So it's still the same thing. So both variance and standard deviation, they are measure of dispersion. But the one, because standard deviation carry the same unit as the original data, you prefer when you are quoting, so plus or minus, you use standard deviation. Any question? So that is the logic. Can you see now? Now, it give you, if you look at it now, the average, if you look at the standard deviation is 1.6. If let's say you even remove, you don't care about this sign before, this deviation, instead of minus, you just put plus, you add everything together, it will give you 5. If you calculate 5 divided by, is it 5 or 6? It gives you 6 rather. 6 over 5. It gives you 1 point something also. It will not be too far from 1.6 you got, but it will not be mathematically correct. Are we together? Now, let's talk about measure of relative position. We have talked about measure of center tendency, the measure of dispersion. Let's talk about measure of relative position. This one is very simple. Relative position, just like I've already told you before. If you are to line up, you are 100 in the class. Let's say you are 100, because we usually use 100% as our standard. So let's say we are just 100 in the class. Then now, according to your position, first position, second position, to the last one. So number one. So if you now say, who is number, if you are to divide the class into half, who is the middle? You know number 50? 50. If number 50% will be the one in the middle. Okay, if we are to divide that 50 into 2 half, who will be in the middle? That will be 25. If you are to divide the other upper 50 from 51 to 100 into 2, 75 will be the one in the middle. So that's why we say, okay, the first 25%, the first quarter, that is the first quarter is 25, the second quarter is between 25 and 50, the third quarter is between 50 and 75, the last one is from 75 and above. So the best way to even usually say is, we say quantile. Okay, don't let me even, let me just look at it. So the word we use here is, we say quantile, relative position. Quantile is the line that divides a particular data set when you have put them in order into equal parts. For example, now, you give you a loaf of bread, you have a twin, a loaf of bread, they give you 9. You want to cut in the middle, you only cut in one place in the middle. That is B. That is the median, the middle. So if you want to cut bread into 2 equal halves, it's only one cut, and that is the median. But if there are 4 children, you want to cut that bread into 4. How many places you cut in 3 places? You first of all cut the first one in the middle. Each of them, you cut them in the middle, make it 3 cuts. Can you see now? So that is why quartile is the line that divides data set 100% into 4 equal parts. Quartile. So the first quarter is the one that ratio 25%. The second quarter is the one in the middle, 50%. The third quarter is 75%. So, and one at those lines are divided them into 4 equal parts. You know, the first one 25%, from that 25% below. The second one, 50%, between that 25% and 50%. The third one is the 75% between that 50% and 75%, and the fourth part is the one above 75 quarter. But if you want to divide this bread into 10, which is decile, you have to cut into 9 places, into 10 equal parts, 9 places. If you want to divide into 100, you have to cut in 99 places. So we use the word quartile, decile, but most of the time it's percentile and quartile we use. But this decile, they are there. We also have pointile. Pointile is the one that divides into 5 equal parts. Each of them 20%. You know, when you are doing research on socioeconomic status, they prefer using quintile. You see, the first, you want to look at the weight of people. The first 20%, the first quintile, second quintile, up to the fourth quintile. There are 4 of them that are divided into 5. You know, quintile that divided into 5 quintile. That is into 5 equal parts, 20%. So look at this way, differentiating between the two of them. This graph here, this picture you are seeing now, the upper part is using quintile, the lower part is using quartile. This quartile, there are 3 lines that divide them into 4, while this one are 4 lines that divide them into 5, 20%. It's being used when you are doing a study on socioeconomic status. This quintile is used more. So cumulative frequency polygon, we said the other time. Can you see? If you remember, just plot the graph. Very simple. Look at mark. Look at this mark now from 1 to 100. What is the median? 60. Can you see? Median is 60. What is the lower quartile? 25% is 45. What is the upper quartile? Between that 75% is 70. Can you see? So that's relative position for you. Then the last one, measure of distribution shape. So the shape, there are 2 measures of distribution shape. This distribution, you don't understand the distribution very well until we do normal distribution. It's other probability. But just know that there are 2, kurtosis and skewness. Skewness is symmetry. Is it symmetrical? That is it when you say something is symmetrical, that one side is mirror image of the other. Look at the middle one is symmetrical, a bilaterally symmetrical, pear shape. But if you look at this other one, they are not symmetrical. One side is not mirror image of the other. And whenever there is skewness, when it's not symmetrical, it's due to outlier. The meaning of outlier is a value that is extremely different from the rest. Let me quickly explain this. When we in this class now, as you are, if we were to measure calculate your age, the age of people, maybe average age, maybe let's say 40-something years, because some will be 20-something, some will be maybe 30-something years, some will be 40-something, some will be 20-something, maybe average will be 30-something, maybe 38 average age. Maybe somebody now brought the daughter that is 5-year-old to join you. So what will happen? If you want to calculate the average together with that one, what will happen? It will jack down, because you know average is total divided by the number. So because when you are now, if you are 50 people, somebody join you in 51 that has a age that is very small, and when you are divided, you are going to divide by 51, not 50. So because of the contribution of that child is so small, so the value of the mean is right. So we know that all of you are different, the age are different. If you're not different, we cannot be saying we are calculating the mean. You don't have the same age. But because that child daughter's age is extremely different, significantly different from other, it's an outlier. Or we now have somebody that brought aged to Centennial. someone that's over 100 years, 102, 5 years to join you. So when you are calculating the average, because the other person has contributed so much, the average age will jack up. That is an outlier also. That one is called positive outlier. The one that increases the average is positive outlier, while the one that decreases the average is negative outlier. So negative outlier causes negative skewness, that is skewness to the left. Positive outlier causes positive skewness to the right. So I don't know if you understand it now. And you just don't mind, this graph is from your, if you are plotting the way they plot this graph, horizontal is the value, maybe the way age we are talking about. Vertical is the frequency. So as you are moving from the beginning like this, so for negative outlier, because the mean is smaller, you get to the mean before you get to the median. But for normal, both median and mean mode and median, they are in the center. Well, for this one also, the mean will be higher than median and mode. We'll explain it better when I don't want to talk it to say anything much about normal distribution until we get to probability. You get to get the picture very well. So then kurtosis is thickness of the graph. So you can see the middle one is okay. This one is flat, platychotic. This one is too big, leptochotic. Whenever the variability is so much, the graph will be flat, platychotic. When the variability is small, there's not much difference in the value between people concerning that variable. And now we say is leptochotic. Any question? Leave this one. Before we go, any question before we go to? No question. I'm scared about this class. No question. So we'll go to the next session. Is there any question? Okay, if there's no question, we have 30 minutes more. Let's go to the practical session. In the subsequent one, there's no much. You see that more as we are proceeding, there's less need. Less need for explanation. We go to the practical session, but this didactic aspect is very, very important for you to grasp it. Anybody that join us after some days now is just wasting time, because you will know that's why they will not understand when we are talking. When we go to the practical session, there are some nitty-gritty they will not understand. They will be dragging us back. I don't understand, because they are not around to get the logic first. So let me share my my SPSS. I've opened. Hope you can see. Let's go to practical session. Now I want to import from. If you open your SPSS, you can see now. I want to import that Excel. The Excel file I gave you. How do you import? So now I will go to File. Now Open. Go to Open. Data. As you can see, it took me to, well, this is where I opened before. But all those data sets I sent to you, you can see them here. But you cannot see the Excel because I'm opening it in SPSS platform. For me to locate it, if you look at this file type, by default is SPSS. So if I want to locate, I will now click on this arrow and now look for Excel. Can you see Excel? And now click. Can you see? Immediately I click. All those SPSS you see there, you cannot see them. You can see the skin lesion, which is Excel. And now click it and open it. Either you double click or click and open. It will give me something like this. We say that by default, read value variable name from the first row. Leave it like that. If it doesn't put it, you have to click on it. If it doesn't check this, you have to check it. Otherwise, it will not give you the variable. Can you see the way I put the variable value? Look at it. If I uncheck it now, you remove it. You will just put V1, V2, V2. You will not V1, V2, whatever. It will not give you, confuse you. But you have to say variable name, the first row. Then just other thing, just say okay. Because it's only one sheet there, and that sheet is skin lesion. Say A to whatever I said, just say yes, say okay. You may not see it. If you see, let me know. Because sometimes, okay, can you see? It went up. I will share it now. You know where it went up. Sometimes you may not see. I mean, no one thing with expresses, when it open new window as you are doing it, that new window is open. I will be seeing it. The view. So I have to now share that window, new window, and open. So can you see now? You can see the Excel. You see, it gives you the variable view. You can go to data view, but it's showing the data view. But if you look at it in that Excel, you have serial number. The data set is 1 to 150, and the age is there. The sex is there, but the sex is not. If you look at it, the way it was entered in Excel is sex, male, female, male, female. So it's no number you put. Of course, that's what you have to do, because if you don't put, how will you know which one or two, if you go and put 1 or 2? Because there's no place in Excel that will help you label it like that or express it. So when somebody is setting Excel, it's better to type that in there. Then when we import it to Excel, express it, we may change all those things. So marital status, can you see? Can you see skin lesion? Whether the person has skin lesion, yes or no. Those are the value. Then we have CD4 count, viral load. Now, what I want us to, if you now come to variable view, you will see that the Excel is very intelligent. Look at the serial number and age, because it's number there. He put them as scale of measurement, scale. And you see, sex, marital status, and skin lesion. Because there are no number, he put them as nominal. Then CD4 count and viral load, he put them as scale. This one is just, I can just delete it. Clear. This other one, empty space. Okay. I did something now. I wanted to save. You know, I've not, since I imported it to, we have not saved. If you look at the title, it gives you on title, it's on title. So I may want to save it. I can now say file, save as. It will save this there where I pick it as SPSS. And that I can say skin lesion. Save. I've saved it now. Now, you may want to do something. You want to, this male, female, you want to make it 1 and 2. Want to make, or make it 1 and 0, whatever you want to do. You can say male 1, female 2, or female 1, male 2. If you want to do that, if you come to variable view, you remember under type where you put string, you want to change to numeric, but don't want, if you change to numeric now, I will lose everything there. Before you can change that thing to numeric, what you do, you first of all enter what you want to enter there first. So for you to do that, I want to change female to 1 and male to 2. If I want to do that, I can right click, I want to sort, so that it will be, instead of you to be doing it 1, 1, 1, 1 like that, you know they are scattered. You right click on the sex, that is the first row of that column. If you right click, you say sort ascending or sort descending. If you sort ascending, female F before M, If you list female first, the female. If you say ascending, male before, whichever way, let's say sort ascending. Can you see? It has sorted. So I will now click on that female, I put 1, and come out, and now click back, and right click and copy, and select all the female, and paste that 1. So I've labeled all the female as 1. The same thing I do for male. I put 2. I go back and copy the 2 and select all the male and put 2. Yes. I can now go now. I've labeled, so I can now go to variable view and now go to the string and say change to numeric. So you can see it's there. If you want to know, you are still C2, but if you want to know what you do, if you come to view, this view, you can see value label is not checked. If you check it, maybe can you see? No, I've not put the I've not put the value label. Sorry. We go to this page, let's put the value label. We have not labeled it. Here, under the value, you say, what did we do? You say 1 is female. You have to put it female, 2 male. So now let's go to that place now. If I come, can you see? Because I check that value, can you see? View. Can you see? For me. This is disturbing me. Some of these icon. I want to scroll up. You can see. So you can see it's 1, 2, or whatever. So if you now say, okay, view value label, it shows male, female. Can you see? But normally I don't like it. I usually off that thing. There is labeled there. The same thing you do for marital status. For example, who can do his own? Okay, let me quickly. Before marital status, it's the same thing. You just sort ascending, or it's descending, ascending, co-divorce. Let me sort ascending. Is it descending? Single as descending. 1 single. You select all the single and make them 1. Separated should be 3. You know, it depends on the alphabetical. That's why it's sorted, but you know what you are giving. Separated is 3. You usually put 2 marry. So 2 marry. For divorce. So you want to label it, you go to variable view. Since you have already put, you are ready, you can say change to numeric. If you go and change to numeric before you put all those numerical value, you lose all the value, because when you change to numeric cannot take later. It will wipe out all the later you have put there. So that's why it's first of all change to the value, the number, before you go and change to numeric. So that's a 1 is single, 2 is married, 3 is separated, 4 is divorce. Yeah. Now, the other one, those are the ones that are categorical there. So I want to stop sharing. I want somebody to share your own and import. Somebody, you have opened your Express, even if you have opened Express, it may not be blank page, it can be something. Just share it. So once you know where you put the data I've sent to you, go and import that skin list, or let's see. because I want you to be part of the demonstration, because there's some other thing I want to demonstrate. So I don't know who will do that. Let me stop sharing. Who will share? Don't tell me you are not using your laptop. Dr. Gazama. Dr. Gazama. If you are muted, you have to unmute if you want to talk. Maybe it's not there. Edebo Onoja. Are you there?
Yes, sir.
So can you share
Yes,
your own?
I'm here.
Can you share your own?
I've been having issues with opening the SPSS.
Which issue do you have open? You have not installed it.
I've installed this, but I followed those instructions, but I'm unable to paste it directly into the file. I've been struggling with it since yesterday.
Okay, what we do now is log by when we finish this something. Immediately log
Okay.
by. You log back to the same Zoom, because it is that's my address is constant. So once I log, I will close the something. You log back.
Okay, sir.
I will ask you to. I will show you. You share what you have done for me with me. I will tell you the way to do it. Some people are having the problem. Okay, who else?
Okay, sir.
Who
Thank
is
you.
bold enough to, because some people can give an excuse. Dr. Garba, are you ready? Dr. Garba.
Yes, sir.
Can you share your own?
Okay, sir.
Uh-huh. Just share that green something. Just share just share the express you have opened. Just share. You have to have opened it before you can share anything on Zoom. You have to have opened it. Yes. Yes, great. Great. Make it why is it not white? Yeah, make it white. Thank you. Now, you know where you store that something. So go to File. Yeah. So scroll down. Scroll down here. This SPSS statistics save does that arrow. Click on that arrow. Yes, go to Excel. Thank you. You can see the skin lesion now. Go and click on it and open. It's like you have not clicked on it, Abi. You have to check it. It's like it's not. You can even double click it. Yeah, yeah, open now. Yes. So you can say okay. It will come up. If the RAM is small, it may take some time. Otherwise, it has opened somewhere. No, it's still the same something. You can stop sharing and share again. Stop sharing and share. Let's see. Maybe it has opened. Dr. Dimas, stop sharing and share again. Yeah, okay, it has come. That's great. Okay, it has even, share again. It has even come. Share again. Everybody, if you don't practice it like this, you will not know it too. Because all those things, some people will be writing down. It's not the writing down. Follow and hand on. So now, I want us to, well, what I've done now, you can quickly do it. Can you quickly do it? Otherwise, you can go and do something else. Can you quickly do what we have just done? Or you leave that one, don't worry. You go and do it later. What we have demonstrated, how you change that something, you can do it later. I want you to run the frequency. Wait, I want to first of all run the general frequency. So if you want to do it now, go to Analyze. Click on Analyze. Go to Analyze. It's up. Go to Descriptive Statistics. Third row. Then go to Frequency. Click on it. So you can move everything. If you want to move everything in, you can just say Control A. If you select everything, you just click on the arrow. You move them into the variable plane. Yeah, move. You may want to, don't click on, okay, yeah. Remove the serial number, because that one, return the serial, click on the serial number and return it. For that one, no, don't click on okay yet. The serial number has not come. Click on the serial number, ensure that it's not, click on only this, thank you. Click on that V8, we even need to delete it. So it's an empty something. Click on the return that V8 and delete it later. Click on OK to run the frequency for all this. Yes. So, you know, it has opened two windows for you. You know, I told you the other time, this is data editor window. Then it has opened result window. That's where the analysis go to. If you want to know, if you hover, I can't see, we cannot see your, if you, Dr. Dima, go to click on the window up, you see. Click on the window. That window beside the help. The window. Your cursor is not on window. Just click on it. Can you see? You will see that you have 1, 2, 3. Where it's giving 1, 2, 3 is that you see the one that say viewer. We have data editor window. We have IBF statistics viewer window. Can you see? That's where the result is. Now number 2. Click on it. So it may not, well, is it your, you may stop sharing and share it again. Maybe your this is not coming out very well. So because it's there, it's on the background there. You can stop sharing and go and share that one. If you go share now, you go to see that window. That's where the result is. Thank you. So you will see. So I don't know how you can make it larger so that you'll be scrolling down, small, be scrolling down. You can see age, be scrolling down, small. Let's see. Be scrolling down. You can see, be going. You can see age now. Be scrolling down. You see sex, be scrolling down. You see marital status. You skin lesion, the value. What you notice, wait here. When you get to, if you know, don't wait. If you continue scrolling and you're going to get to significant viral load, now you see that all the quantitative variable there, they are line list, they are too long, but the categorical variable, they are already classified. Can you see now? Ready to put on your, if you are doing your analysis now, you can just carry this one, go and put it on your table in your Word document. This is marital status, divorce, this thing. It's because we didn't label it. If we have labeled 1, 2, 3, it will arrange it for us. Single will come first, but it doesn't change anything. The frequency is the same. So you will see that for categorical variable, it's already, the percentage has given you, they are giving you the, If you remember, was a frequency distribution and relative frequency distribution have been given to us. Relative frequency is the percentage. Percent is the relative frequency. The value itself is the frequency. And you see now, we are talking about the 4 types of distribution: frequency distribution, relative frequency, cumulative frequency, and cumulative relative frequency. But the issue is that we don't use it on rare occasion. We use that cumulative aspect. But what we need is in fact, the frequency and relative, the value and the percentage. And that's what it gives to you. Can you see? You see the cumulative percent is the last. Can you see? But it's not useful in every situation. It's only if you scroll to age now. Age now is from scroll up to that age. You see, cumulative frequency make sense in the sense that is the value are arranged in ascending order. Scroll to the beginning. The value are arranged in ascending order. Okay, it's okay. You see, it will give you, it's okay. The percentage for 18 years is 0.7. Can you see cumulative? 0.7. For 19, it's 0.7. But when you now add it, it will keep on adding it. If you scroll down now, the total cumulative percent will be 100. Can you see the way he does it? But you don't even need it now. But now, you see that for qualitative variable, we are done with it. But the problem is with the quantitative variable. How do you present your age? You may want to arrange it. We are going to calculate the mean, no problem. But normally, even before you calculate, you still want to show the age range. How do you do that? You have to group. How do you group? Yeah, go to transform. You can go to it here. That one thing with essay, both in the data window or on the BI view result window. Yeah, you can actually access all those icons. Go to transform, Dr. Dimas. Click on transform. We want to group. So you now see, you see option recode into different variable. It's now numbers. Yes, you can see. Yes. You see recode to the same variable. Do you ever use that one? Click on it. If you use recode to the same variable, it will record and knock out and delete the original variable you are recording. So I don't know why they even put the option there. It's not supposed to be there. They recode to different variable. Now move the age into that box. Age. You see, it say A into put arrow. What? You want to record A into what? So come to name or that output variable under the name. Put age group. Age, don't put gap, or it will not take from you. Age, capital, I prefer capital G. The way I do capital G, those G, you can even GRP. That's all. Yeah. Okay, it's okay like that. And I just say GRP. Yeah, this age group. So now you click on change. Click on it. Immediately, that question mark, you replace that age group to that. You see, it's telling you are changing, you are recording A to age group. You will see something like label. That label, this age you put here, it will not allow you to put gap. But if you want to label it, put gap, you can. But I don't usually do that because, as I've already told you, when you label it, is that particular label that will be showing. Me, I prefer shorthand, the way it is like that. So you don't need to label it. Now, you go to old and new. Go to old and new. Click on old and new. Click on it. So now, there are different ways you can do this in here. So here now, we want to read. We know that if you have explored the data said the lowest age is 18, the highest is 95, I think. But the issue there is that even if you don't even know the lowest, but you must have idea of how you You might have gone through when you analyze, go through to see the way you have to make up your mind how you want to range it. For this data now, let's range it anything below 20, 20 to 29, 30 to 39, 40 to 49, 50 and above. Even though the highest age, sorry, is it 95? No, it's 56. The highest age 56. The highest age. So now, what you do now, click on this range lowest true. Click on it. Click on it. Click on that range lowest true. You have to click on that thing, highlight it first. Click on that, and thank you. So that's where you can type something. So what it's telling you is that the lowest you want, that is the lowest something and below. So you want to put 19 and below. Anything less than 20 is 19. Even though if you have studied the data very well, you can say 18 to 19. It doesn't matter. You can come to up here as a range 8 to 19. But here you can just say 18, put 18, put 19 rather, because you want to do anything at least 19. Put 19. Click 19. Click on value, come up here and put 1. Value up on the right side, upper side, right upper, right upper. Yes, put 1. Hard. You see, immediately that had something come up. Yeah, what you have done, lowest through 19 means in group 1. Yeah, come up now. Come and click on that range on the left side. Range. 20. Yeah, put 20. 20 through 29. 20. Then through 29. You have not put 29. Okay, 29. It's 39 you put. 29, 29, not 39. So value 2. Go and put value as 2. And hard. Then 30 through 39. All people are getting it now. You can be doing that even on your own laptop. Theory. 40 to 49. Four. You can now say range, come to range IS, value through IS. Click on it. You can say 50, just put it, that is, it means 50 and above. So go to value and put 5. Hard. Continue. Great. Okay. Click OK. You have not finished your OK. Now, I want you to share something now. You have to stop sharing this and share your data editor window. Share this one. I will show you the age I've put in data editor window now. The age group. Share the data editor window. It's because we are using Zoom. That's why we have to be sharing. But normally she can see it. She has it there. She can easily access it, but she has to share for us to see. Thank you. You will see. Can you see the age group you have created now? All those labels. So, but you have no label and say, okay, this theory mean so. If you want to do that, you now go to your data before data view. Yes, data view. Yes. Come on. That age group now come. You know it's the last thing you created. Come to the value. Come to the value now. Value, the column is not label. Value, the one in front of it. Is row number 9 now. Age group you just created is the last variable. Come down. Yes. Yeah, click on it. Yes, 1. Yeah, put 1. Less than 20. Use less than as the from your computer. Less than sign from your computer. Oh, it's not in your computer, it's there. Your keyboard. Less than in your keyboard is there. 20. Hard. 2. 20 to 29. Just 20-29. -29. Hard. 3. 30-39. 4. 44-49. 5. 50 plus. So, because it's supposed to be greater than or equal to it. That one you have to go inside. You cannot get it here. What I usually do is that I can go to Word document and look at the symbol, I put it on Word, I copy, but now they just 50 plus. Hard. Okay. These things give you 2 decimal places. Reduce this decimal place to 0. The decimal so that all those nonsense will not be showing. Yeah, this is a 0. Thank you. So now you can go to analysis now, analyze. You see, you can even access analyze from here. Descriptive, frequency. So all those things you are doing, you can control A on them and return them. The one you have analyzed before, go to the don't want to run all that. Just control A, it select all of them and return them, and now moving the age something. Age group is down. You have to scroll down. It's after that V8. Scroll down. The age group you just did now is down. You have to scroll down, yes. Move it. Okay. So you have to share. Stop sharing and share the result view. It's in result now. And share the result view. Result window rather. Be ready. I will call anybody because it's not this is workshop. Can you see now? It has given you the frequency for the age group you have done. That's how to group with the computer. That's how you can do it for all the quantitative variables. Now, you may want to know your mean. You want to know what is the mean age. You go to analyze. Go to descriptive statistics. Descriptive. Under it, go to descriptive. Descriptive, yes. Move age in. Not age group, age, the original age. It's not age group. It's not age group, the original age, yes. Click OK. Can you see? It has given you the mean. Can you see? It gives you minimum, maximum, mean, standard deviation. Can you see? But if you want to know more, you want to know the median, interquartile, there are different. Yeah, go. If you want to know more, go to analyze. Go to descriptive statistics. Frequency. Click on frequency, not descriptive now. Frequency. Remove that age group. Put the original age there. And click on statistics. You can see mean, median, mode. You can click as many you want to know. Even quarter, first quarter, variance, anything. You can click, and as many you want to know. Mean, median, mode, standard deviation, minimum, maximum, skewness, kurtosis, standard error, range. Can you see? Anything you want to know about all those things, all those things we are talking about, you can click it and click continue. Then click continue. Hey, before you click OK, if you don't want it to display, if you can look at display frequency, you can uncheck it before you click OK. Have you clicked OK? Uncheck it, because if you don't uncheck it, it will go around the frequency again, for which we don't want for this case now. Click OK. Can you see all those things? They are here. It give you the mean, the median, the mode, the standard deviation, the variance, minimum, maximum, first quarter, second quarter. Can you see all this percent? They give it to you. Now, you may want, there's still one exploration we want to do. Now, before we do that exploration, now imagine you want to, we're talking about splitting. Somebody was asking me a question about splitting. Maybe you want to run this age group you have just done, or anything, analysis for male and female separately. What will you do? Go to data. You want to run some analysis separately for two group of people. You want to split. Go to data. Click on data. Click on it. So come down. You see split file. Third to the last. Split file. Yes. Click. Click on it. So click on analyze output by group. Number 2, by default, it says analyze all cases, do not create group. That's what you have been doing. That's default. Click on that number 3. And now click OK. Before you want to split by, what do you want? You want to split by sex. Put sex inside and move it inside that place. So you want to split by sex. Now click OK. You just done it. You have not run anything. Now let's go and run. Let's run that age group we did that time. Yeah. Go to analyze. If you have questions, let us know. Some people are ready to sleep here, I know. Then frequency. Click on the frequency. Wait, you have to go and do something. You have done something. Go to that statistics. Oh, okay, first of all, remove the age. Remove the age. What we want to do is the age group. Remove that age. Or it may even, listen. Even this analysis we have done now, we can do it, don't worry. Just go back. Just continue. What we just did, that you can even do it. Yeah, continue, don't worry. Simple, good. Continue. No, don't remove. Just say okay. Okay, yeah. So what it will do it separately for male and female. That's just whatever analysis you are drawing. Can you see now? It says sex, female, sex, male. Can you see now? It did the analysis separately. Any analysis you want to do separately for maybe you are dealing with urban and rural. If urban and rural is you split by urban and rural. But there's something I want you to do. Go back to that data. You see, instead of separate, you put it in one table. Yeah? Go to the data. Go back to that data. When we say split file. Split file. Click on that split file. So now click on compare group. Instead of say organize attribute by group, click on that second option, compare group. Yeah, click OK. So go to the analyze again. Yes, you see what happened. Go to the analyze and you run that thing. Frequency. Okay. You see now, it put it in the same table. Yes, I'm now. So put it together. So that's this second option. That second option in the middle is better. I just did that one so that you know that those are different options, but this one is neater. He put it together instead of separating, though it's still female and male, but he put it in one table. So any analysis you're doing that, I just say compare, you click on that option, compare group. It will not that it will compare anything statistically, it just means that you put in the same table. I think we stop here. Or do you have any question? Or should we continue? Because there are many things to explore. But I know that this is after 10 and some people are already sleeping. Any question? Tomorrow we continue. Tomorrow we are going to discuss what do I call it? Normal distribution. What do I call it? Probability and normal distribution. That one we do some exploration also. We still do some exploration. This is where until we will not start chi-square all those things until after maybe, because after normal after that one we'll not do inferential statistics. It's after that one we'll now start. So but for each day we do some exploration so that you get to understand some of those things before we go to specific tests of statistics, hypothesis tests. Any question? No question. Okay.
Sir,
Yes.
good evening, sir.
Good evening.
Yes, mine is not really, my own table is not showing exactly the way his own is showing. It's
Okay,
showing
stop
with
sharing,
lines.
Dr.
It
Dima.
doesn't
Let her
have
share her own
this
table.
that.
Share your table. Let's see. Share your own. Share.
Okay.
Click on that green arrow. You are not sharing. So you say your own table. Share. You will share the output you get now. Share the output. Click on that output here. Then you say it's not. What do you say is not showing? But you did it now. What is it not showing?
Sir, I don't know. It's just showing a plain table. I don't know if I have to edit it or.
No, it's not showing all this grid line, all right?
Yes, sir.
No, it doesn't really matter. I think it depends on maybe it has something they express. Even my own, when I show, it usually show like this. That one doesn't mean anything.
Okay, sir.
It doesn't mean
Thank
anything.
you, sir.
Yeah. So click on this table, double click on that table you are seeing. I just remember something.
The
Double
age
click.
group?
Yes, double click on it. So sometimes if you double click on the table, it's supposed to you can edit the table.
Sir?
As you have double click on that table now, it has
Yes, sir.
changed to a window called table editor window. You know, we say this result window, the attribute window. It
Yes,
has,
sir.
you can enter into, if you plot graph, you can double click on the graph and edit the graph. You can double click on the graph and edit the table. This, now that you can edit the table, now it has entered into another window, which is table editor. It's just like you enter your bedroom and inside it you have toilets. You look at the picture, you have another, you can open another door to another thing. I just want you to
Yes,
know
sir.
that, for everybody, I'm talking to everybody now, for you to know that, there are many windows in Express, but the two common is data editor window, the sort or output window or viewer window. Then inside the viewer window, you can enter into table editor window and data graph editor window. Thank you. I think we close for tonight. Any other question?
Thank you, sir.
Welcome. So other people should be ready to share tomorrow. I can call anybody, be ready, make your computer ready, make the data ready. It's when you practice, you know it too. So if I don't allow someone to do that, you will not know it. Me, I'll just be doing video, and it's not like that. The way it's on, you should do to participate. And that's why I've shared the data with you. To anybody, I can say, okay, import so data, we want to work on it. Thank you. Good night, everyone. So tomorrow, the same time. Yeah.
Thank you, sir.
Thank you, sir.
Good night. Thank you.